Okay, we're ready for the final talk of the session, which is improving generalization ability in a puzzle game using reinforcement learning. And as I mentioned, there's a really cool puzzle game called Geometry Friends that's been the subject of a number of competitions. It's a very tough puzzle. I think there's not attracted many entries because it's so hard, but we're going to find out about how reinforcement learning can be used to do this. And the speaker is going to be Hiroya Unishi. Please give your talk.
Thank you. Hello everyone. I am Hiroya Onishi at Kyoto Institute of Technology. Today I'd like to talk about improving generalization ability in a puzzle game using reinforcement learning. Nowadays, machine learning has attracted much attention in many fields, such as speech character recognition and gameplay. However, in order to apply to various problems without relearning, its generalization ability is needed. And Geometry Friends is a puzzle game where sufficient generalization ability is needed. Geometry Friends is a puzzle game where a player controls a character which collects targets in a two-dimensional world within a time limit. And the competition used this game has been often held. In the existing method based on reinforcement learning, the problem of Geometry Friends are divided into these two problems: finding the character's path and selecting character's action to follow the path. And the problems are solved. Reinforcement learning is useful to solve the second problem. However, there are too many states to run optimal action for all the states, and so it doesn't necessarily have the generalization ability. So we'll propose a method based on the reinforcement learning for Geometry Friends. In this method, generalization ability is improved. I'll explain the details of Geometry Friends. This is the screen of this game. Yellow circle is a character, and the purple diamonds is a target. Character can roll left, or roll right, or jump. The objective of this game is to collect all the targets within a time limit. In the existing method, in order to collect all the targets, these two problems are solved. Finding the shortest path to collect all the targets and selecting characters' actions to follow the path. I'll explain the reason why must the path be found. In this level, if the character collects the left target first, the character cannot collect the right one because the character cannot reach this from this position by jumping. On the other hand, if the character collects the right one first, the character collects all the targets. So such paths must be found. In the existing of the method, the problem of selecting the actions is solved by reinforcement learning. However, there are too many states to run optimal action for all the states. In the proposed method, these two problems are defined: path find problem and action selection problem. This problem is similar to those of existing method, but different. And in order to overcome the disadvantage of the existing method, when the path found problem is solved, we extract useful information, which makes the action selection problem easy to run. And in order to acquire generalization ability, methods for the two problems must be effective for any level. Then I'll propose a method to solve each problem. First, I'll propose a method to solve pathfinding problem. I'll explain the idea of the proposed method. We call a flat obstacle which the character can get on a platform. The character can collect each target by moving over a platform or by jumping or falling from it. So I define the path order of platforms the character must move to. And we apply a search algorithm. We generate a directed graph whose node corresponding to the platform and whose edge is given if the character can move from a platform to another platform. And we apply a search algorithm to the graph and find the shortest path on the graph. I'll show an example of generating the graph. The orange circle represents a node of graph. And the red arrow represents the edge. For example, the character can collect from from this platform to edge is given if the character can move from a platform to another platform. In order to generate the directed graph, the following information is required: platform to which the character can move from each platform, and the targets which it can collect from each platform. This information is obtained by predicting the trajectory of the jumping or falling character. So, the proposed method consists of these four procedures. First, we predict the character's trajectory. Second, we obtain information on platforms and targets. Third, we generate the directed graph. And finally, we apply a search algorithm to the graph. First, I'll propose a method to predict the character's trajectories. The trajectories differ among different levels because the position of the obstacles also differ among different levels, and the character collides with the obstacles. So, in order to predict the trajectory in any level, we predict the trajectory for these two cases. First case, no collisions with obstacles. And second case, a collision with an obstacle. Until the collision, we use a trajectory for the first case. Then first I do propose a method to trajectory for the first case. And we assume the trajectory of a jumping or falling character is a parabola. So we can formulate the trajectory as and we can define the trajectory as these equations. T is the time and set as 0 when the character begins to jump or fall. And X and Y is abscissa and ordinate of the character. And the origin is set as the position of the character when T is equal to 0. and Vx and Vy is respectively horizontal velocity and vertical velocity when t is equal to 0. And g is the acceleration of gravity. If we can Vx, Vy, and g, we can obtain these values, we can predict the trajectories. Trajectory is x and y. However, Vy in the case where the character jumps is unknown, and g is also unknown. So, in order to estimate the value of the value Vy and g, we solved an optimization problem. We call the estimated value of Vy and g respectively Vy hat and g hat. And the objective function is defined as these equations, where y hat is calculated by substituting Vy hat and g hat into the trajectory of the character. And to solve the optimization problem, we apply stochastic gradient descent. In one iteration of this method, the estimated values are updated by this equation, where alpha represents learning rate and nabla ft bar represents gradient of ft bar. And in order to update Vy hat and g hat, we must obtain y at a time t. So, in each iteration, we make the character jump and obtain y. Then I will propose a method to predict the trajectory for the second case. We assume that after colliding with the obstacle, the character simply falls straight down. It is confirmed empirically that this simple movement is similar to the real movement. Next, obtain information on platforms and targets. We obtain the information by using the predicted trajectory. In this figure, this target is on the trajectory, so this target can be corrected by the character. And similarly, this platform, the character can move to this platform. And the following information is obtained. The position in which the character jumps or falls, and the velocity, and its movement. Movement means jump or fall, and the target it can correct, and the position in which it lands. And then generate the directed graph. As mentioned before, we generate the directed graph whose node corresponding to the platform and whose edge is given if the character can move from a platform to another platform. So, in this level, the directed graph is generated as shown in this figure. And the obtained information, such as the position in which the character jumps or falls, velocity, and so on, is set as the property of the edge. And the cost of the edge is defined as the length of the arrow. The character at the current position of the character, distance from the current position of the character to the position in which it lands via the position in which it jumps or falls. And finally, apply such algorithm to the directed graph. In order to find the shortest path in the graph, subgoal L star is applied. Subgoal L star is an improved L star such algorithm and can find the shortest path to collect multiple targets. I'll show one example of the found path. The red line represents the found path. In addition, we can extract useful information. These useful information, velocity, jump. So by making the character reach the orange circle position with the velocity and jump, and the character can move onto the next platform. So by doing it repeatedly, the character can follow the path. Next action section, I'll propose a method to solve action section problem. In the existing method, to solve the problem, reinforcement learning is used. However, there are many states to run optimal action for the states. On the other hand, in the proposed method, the extracted information makes the action section problem easy to run. So, and in order to follow any path, the optimal actions to reach any target position with any target velocity must be obtained. To run such action, we apply Q-learning. And we perform the learning only for a specific target position. For this purpose, we should define the actions and states appropriately. Action is set as roll left and roll right. And the states is set as defined as distance from the character to the target position and the horizontal velocity of the character. In this figure, D represents the distance and Vx represents the velocity. By defining the state so, if the D and Vx have the same value, although the target position is different, this case is regarded as the same state as the previous one. So by the learning only for a specific target position, the optimal action for any target position is learned. And the reward is defined as plus 200 when the character is the target position with a target velocity, and minus 1 in the other states. The optimal actions depend on the target velocity, so we perform the learning independently for each target velocity. This is the level useful for the learning. And the target position is set at the middle of the level. We conducted experiments whose objective is to show that the proposed method improves the generalization ability. We mix these three AI players play geometry friends. Our AI player, designed by the proposed method, Agent Alpha, designed by the existing method based on reinforcement learning, and CI bot, which is a winner of CIG 2014 competition. Each AI player plays at 10 levels using CIG 2014 10 times. This is the result. A vertical axis represents the levels. Horizontal axis represents the levels, and vertical axis represents the average collected targets. And the red line represents Agent Alpha, green line represents CI bot, and blue line represents our AI player. In any of the levels, our AI player creates more targets, so the proposed method improves the generalization ability. I'll show a video where where our player plays geometry friends. This level is unknown to our player, but the character successfully collects all the targets. Finally, I'll conclude my presentation. We have proposed a method whose generalization ability is improved for geometry friends. In this method, the following problems are defined: pathfind problem and action section problem, and solved. And from the experimental results, the proposed method improves the generalization ability. This is the end of my presentation. Thank you for your attention.
We have a few minutes for questions. Who wants to go first? Maybe I can just start with an observation. So the competition is called Geometry Friends, but this guy didn't have any friends. There was just one. So it's a serious question. I mean, in the full version of the competition, there's a square character as well, who kind of compresses to make variable-sized platforms. So have you thought about doing the full version as well? So you understand what I'm saying? You just got the circle character.
Yes.
In the full version, there's a green square character as well.
If we regard the rectangle as obstacle, then
So it's not an obstacle. The green character rectangle is a cooperative character.
yes.
In the full version. So my question is, have you thought about how to address the full version that also has the green compressible rectangle in it?
Sorry, it's future work.
Future work. Okay.
Sorry.
Do we have any other questions? Yeah, one here.
It's just to ask, was this new technique used in this year's competition? Because you have an entry from your university in this competition 2017.
I participate in competition.
This year?
Yes.
With this? Okay.
Yes.
So just to clarify, this was the bot that won the competition this year.
Is that right?
I think so, right? This won the competition this year.
The result of competition I have not seen yet.
So it was announced yesterday because I was.
Yeah, I announced it. Yeah, but I was clarifying if it was this one, the bot with this technique that won the competition. That was I was asking him.
And
No.
I think it's an interesting point. Does anybody here know whether this was a competition winner this year or not? It was. Right. But yeah, no. That's what I'm trying to. That's exactly what I'm trying to clarify. Yeah. Okay. Yeah.
Thank you.
So I think we do have one more question, Vanessa.
Well, it's just a quick comment to what you asked before, because to Dortmund, we're actually running a similar competition, just we're removing the physics-based stuff and just focusing on the path planning. So there's flyers there if you're interested. But we had a couple of students who did a very similar thing, and they actually had different kind of edges for the ways the different characters can collaborate. So this is actually a very good thing. So I think if you integrate the square character in the similar way, then this would actually be very helpful, and that could work.
Thank you.
Thanks. So I think that's it for this session. So let's thank all the speakers again. Thank you very much. And I've got a feeling that there may be some announcements, so don't run away just yet. I
don't know. Let me start. Okay, so I have a couple of announcements. So first, very easy. Over there, we have a table with some material where people advertising books and competitions and call for papers. And if you're interested in any of these things, I encourage you go over there and check that one out. Also, tomorrow morning we're going to have a very interesting keynote panel. There's going to be like 5 game designers here who are going to talk about like the relationship between game design and academic AI research and how this feeds into each other. So I encourage you all to attend this. I think it's going to be very exciting. And finally, from my side, I don't know what Julian's going to say, but from my side, there's been some questions about the social events tonight. So what's going to happen is that you now, after Julian is finished, have some free time. And if you want to join us at 8 o'clock, there's basically 3 options. Maybe you have signed up with Andy's Magic Draft, and then you meet up here at 8 o'clock. If you haven't,